Hi, I am Tammy and I do math for coffee. Today we're going to talk about how to tell if two lines are parallel by looking at their slopes. Is the red line parallel to the blue line? You still need to find out if they have the same slope. Now in this one it's pretty easy. If it's on a graph like this, you can count the boxes. And remember, slope is rise over run, so this is what I'm looking at right here. So to get from this point to this point, I have to go down 6 over 2. And for this one, I have to go down 3 over 1. So you can probably tell, but just to prove it with the math, -6 divided by 2, is that equal to -3 divided by 1? And yeah, it is. -6 divided by 2 is -3. And -3 divided by 1 is also -3. So the answer is yes, these two lines are parallel. But you got to be careful because sometimes you're looking at them, it's going to look like they're parallel and they're not. You always need to check. Like this one. I'm telling you the answer is no, but let me prove it. So on the red line, I have to go up 1 over 3. And on the blue line, I have to go up 2 over 5. So then to prove this to your teacher that you know what you're doing, you're going to go, is 1/3 equal to 2/5? And if you put a little question mark over that, that means you are saying you're not sure yet, but that's the situation that needs to be true if they're parallel. And they're not. They're not the same at all. And to check that, you could cross multiply. Take 1 times 5, that's 5. And then take 3 times 2, that's 6. If those numbers don't match, if those answers don't match, then these two things are not equal. So the answer is no. These are not parallel lines, but they're so slight, right? So you got to check the math. Are these lines parallel? And this is more likely what you're going to see. They're going to just give you the points and they're not necessarily going to be on a graph. The slope formula from algebra is this: y2 minus y1 over x2 minus x1. And what symbols are talking about are these different coordinates. So for the first point, I'm going to call this my x1 and this my y1. And this is x2 and y2. And these little subscripts are just talking about x's and y's that belong to different points. And if we had a third one, we'd have x sub 3, y sub 3. That's how that would work. All right, so using the formula, y2 minus y1 on top, and x2 minus x1 on the bottom. So it's going to be 20 minus the 15 over 14 over the 11. This is the slope formula. Now we're coming up with the slope for the line that goes through these 2 points. It's 5/3. 20 minus 15 is 5. 14 minus 11 is 3. That doesn't tell us anything about parallel yet. That's just telling us the slope of line 1. We're going to do the same thing for this one. 19 minus a -16, 20 minus a -8. Remember, if you have two negatives popping up next to each other, that's going to change to a plus. So this is going to turn into 19 plus 16 over 20 plus 8, which becomes 35 over 28. That is not in lowest terms. What can go into both 35 and 28? 7. Let's divide top and the bottom by 7, and we end up with 5/3. So the slopes match. That means, yes, these are parallel lines. Let's do 7 minus a -8 over 0 minus a -10. That's going to become 15 over 10, which reduces to 3/2 if you divide top and bottom both by 5. Line 2, -19 minus the -1. Remember, the y's go on top. The most common mistake in working on slope with the slope formula is people like to put the x's on top because x comes before y alphabetically. But for this, you got to have the y's on the top. Rise over run. The rise is the y's. So I've got -19 plus 1, and then 1 minus 13 is -12. That's going to get me to -18 over -12. If I divide top and bottom by -6, you probably would have thought of the 6 first, but there's negatives on both of those, so I'm just going to use -6. I get 3/2. And yippee skippy! We have another yes. I think we're ready for a no, right? You know how teachers work. You have 2 yeses in a row, there's going to be a no. Oh, it's different. Instead of giving you the points, I'm giving you the equations. Is y equals 4x plus 3, that's line 1, is that parallel to y equals 4x minus 5? If you know the trick, this is deceptively easy. Y equals mx plus b. Remember that from algebra? The m is the slope. No matter what this b is, that doesn't matter. You can ignore it. Just go ahead and put your thumb over it. Parallel lines will have the same slope. And so if these equations have the same number, then you have parallel lines. So this is the slope of this line, and this is the slope of that line, and they both equal 4. So we have another big yes. Yay! I need a no. Oh, here it is. You guys see it? Remember, m is your slope. For this one, line 1, the slope is -2. We don't care about the 14. We only care about the slope for this problem because we just want to know if they're parallel. The slope is -2, and over here the slope is 3. There's our big no, not parallel. Okay, now Karma's all set. You don't know what's going to be the next one. What do you think? Well, line 2 is looking pretty nice because it's in slope-intercept form, which is what we like. We can look right at it and see what the slope is, which is sweet about that form. But line 1 is in standard form. You cannot tell what the slope is unless you do some either math on paper or math in your head. And me doing math in my head makes for a really boring video. So I'm going to do it on here. I know the slope is -2 there. So what we're going to do is solve for y. Make y by itself like it is in the formula. So the first thing I'm going to do is take the 4x away from both sides. So I get 2y equals -4x plus 10. I didn't write 10 minus 4x because that's out of the, everything would be mixed up according to the form we're trying to get it in. So I just put the minus 4x first and kept the plus 10. Now, I don't want 2y, I want 1y. So I'm going to divide every number by 2. And I get y equals -2x plus 5. So now I can see that the slope of my line 1 is also -2. There's a yes. These lines are parallel. If I would have gotten any other number besides -2, the answer would have been no. The next lesson is going to be writing equations for parallel lines, and when that's ready, it'll be a link for you right here. Otherwise, check out the playlist for the whole class, and I will see you in the next one. Oh, thanks for watching, and like and subscribe and all that stuff. Bye!